Hello all, I'm Shahid from Hasira. So we'll be looking at some of the basic concepts in Kubernetes, and probably creating a typical or deploying a typical application onto a Kubernetes cluster. We'll also go through the steps to create a Kubernetes cluster on the cloud as well as locally. So I'm just waiting for a couple of minutes more. Cool. So let's start. So the best place to get started with Kubernetes is the official website itself, kubernetes.io. So there are a lot of interactive tutorials, a lot of documentation concepts, everything, a lot of things in this website itself, where you can try Kubernetes in the browser. So what I'm going to do is this you can go through yourself. What I'm going to do is use a Kubernetes cluster on Google Kubernetes engine and interact with it using the kubectl command line tool or kube control command line tool. And then we'll try to deploy one or two applications onto the cluster. So first of all, what we need to do is to download Kubernetes. So how we do that is we go to setup. Okay, yeah, so we will download the current release. We will download client binaries. So we'll just download kubectl. So this is the command line tool that we are going to use and interact with the cluster. What we have here is a couple of download links for macOS, Linux, and Windows. I already have this installed in my terminal, so I'm gonna be using that. I'm gonna increase my font size a bit so that you can see what's happening. Medium 12. Okay, I think this is enough. Cool. So I already have kubectl installed. So if I say kubectl version, it's gonna tell me what version it is. Right now, it's trying to contact the cluster also for the version. That's why it's taking so much time. So in the meanwhile, let's see how we can create a Kubernetes cluster. The easiest way to get a production ready Kubernetes cluster is to go to Google Cloud Platform. You can go to console.cloud.google.com, and there is a $300 free credits program that Google is providing. You can go to Google Cloud Platform, sign up, and go to Kubernetes engine, and then you can click this button to create a Kubernetes cluster. So I'm going to use this for now. So anybody's entitled to get $300 of Google Cloud credits, and you can use it for creating Kubernetes clusters also. So we'll just create a cluster. I'm going to call the cluster webinar cluster. So I'm just going to put it in, let's say, Mumbai, Asia, South 1A. Now I'm going to choose 1.7 for now. I just need one node. Don't need a lot of to create. So if you're dealing with Google Cloud Platform, you will need one more online tool, which is called G Cloud. So you can also install G Cloud. Googling install G Cloud. Go to this page and get the installation instructions. So once our Kubernetes cluster is ready, we'll have a connect button here using which we can connect to our Kubernetes cluster. So we can see that our client version is 1.7, 1.7.0. It's pretty old. I have installed it a couple of months ago. The current version is 1.9. Uh, there are a lot of features being added, but nothing very drastic have happened. Okay, so while our cluster is getting created, let's look at couple of concepts in Kubernetes. I am starting with the assumption that all of you know what containers are and you know how you have used Docker. Docker is the command line tool, or Docker is the daemon system that we use to run containers. And the Kubernetes clusters that we create right now are also going to use Docker as a container runtime. So I'm going to do, okay, they already exist. So, okay, it is 101. It's still getting created. Okay, the connect button is available. So this is a gcloud command to connect with the cluster. Just execute this. Okay, the cluster is not running. It's still not ready. So what we're going to do is, so Kubernetes, the building block is called a pod. Pod is a collection of containers, and what you can do is, let's look at a simple pod manifest. This pod. I have not prepared any slides or anything for this. I'm just gonna be showing you how a normal person would do this, searching the documentation and looking at examples here. So a pod is, you can consider a container as a pod, but you can group multiple containers also together as a pod. So what we need here is to get a pod manifest. So this should be your one-stop place for all Kubernetes related documentation. So Kubernetes pod example YAML. This is how a pod is going to look like. So the basic understanding about Kubernetes is that there is a cluster which is running. I'm going to connect to it again. Okay, so I have the cluster connected, and there is a client which is called kubecontroller kubectl, which is going to interact with the cluster, and you can do a lot of actions. One of the actions is get nodes. We can see that there is one node called GKE webinar cluster. It is ready since 52 seconds. Version is 1.7.12. So the idea here is that you deploy your applications onto the cluster using this command line tool. And the cluster will take care of all the procedures involved, and it will make sure that the application is running all the time. So an analogy could be where you have a VM and a lot of processes are running on the VM, and there is somebody who is going to monitor these processes and restart them if some of them fails. This can be a person, a sysadmin who is sitting somewhere and managing this VM. So an analogy would be Kubernetes is this sysadmin who is going to manage all your VMs. You are going to just tell the sysadmin that, hey, I want this application to be deployed. The person is going, or Kubernetes is going to decide which node it should get deployed and how the deployment should happen. And it also takes care of failures. So it's going to restart the application in case errors happen, etc. So I'm going to just show you a multi-node environment. I'm going to scale this to 2. So I'll have one more node ready in the meanwhile. So the way Kubernetes interacts with the way kubectl interacts with the cluster is through uh, REST APIs. So if I do kubectl get nodes, the actual thing that is happening is I'm interacting with the cluster through this YAML or JSON files. So this is the YAML representation of the node. You can see that kind node. So the basic workhorse in Kubernetes is a node, and you can create things like pods, deployments, replica sets, daemon sets, stateful sets, etc. And these objects will be created on nodes. So a simple example, as we saw, a pod. The pod is a basic building block. So here you can see this is a pod for Nginx. It says kind pod, containers, and name Nginx. Image is also Nginx. So we can copy this YAML file. I'm just gonna copy this YAML file here. We have example pod.yaml here. Remove whatever the app was. Nginx. I don't need this. Container is Nginx, image is Nginx, container port is 80. So now, the moment I create this, Kubernetes is gonna create a container in this node with the corresponding image that I gave. So kubectl create -f example pod.yaml. This is gonna create the pod in the Kubernetes cluster. So it says pod Nginx created. So if I do kubectl get pods, you can see that Nginx is in container creating state. Now a higher level abstraction above pods is called namespaces. Namespaces is going to show me that there are a couple of namespaces available. A namespace is nothing but a system to group together certain resources. So if you look at kubectl get pods -n means namespace, kube system, you can see that a couple of system components are already running. These are specific to the Kubernetes installation that we have just created on GKE. So let's look at the status of our Nginx pods again. Nginx pod again. So it says Nginx is running, but how do we access this Nginx application, right? First of all, let's see that kubectl get pods Nginx -o YAML. You look at the pod. There are a lot of other information that has been added. Another way to look at a detailed status is describe. So describe pod Nginx. So we can see that its image is Nginx, port is 80, it's running, lot of other stuff is there, lot of Kubernetes events are happening. So now we are going to look at, so let's say we are running this Nginx container here. Okay, docker run -t 80:80 Nginx. We're going to add -it and -rm. So this is going to pull the Nginx image because it's not found locally, and it's going to run the Nginx container here in my local system, right? The exact same is happening, but everything is managed by Kubernetes. So now when I look at here, I said that bind my local port 80 to the container port 80. So that way, if I go to local host, I can see that Nginx is running localhost colon 80. So the say and the logs are getting printed here. So I'm going to cancel, close, stop the server now. Similarly, we can see that Nginx is running on this Kubernetes cluster, but how do we access it? let's go back to the uh, Kubernetes cluster dashboard, Kubernetes engine dashboard. We see that this is our cluster. There is an IP address here. So this IP address is gonna give you access to the API server. What we're gonna do is kubectl. There's a command called kubectl proxy. It's going to run the API server in our local through our local host. So what we're gonna do here is we'll go to localhost 8001 where the proxy is running. We can see that a lot of endpoints are shown here, right? So there is a particular thing called proxy, which can proxy stuff uh, to the okay. And I will change this API v1 default proxy here nginx. Okay, let's figure out what the proxy URL could be. kubectl proxy API running pod. Cool. So when we look at this, the only way to connect to a pod is via something called a service, right? So a pod by itself is just a container. It's just a container running. To access any containers running through HTTP APIs or anything, we need something called services. Kubernetes, kubectl get services. So this is going to tell us that there is one service called Kubernetes running, and its IP address is this, and there is no external IP, and it is listening on port 443, right? So a service is, you can consider it as a front end for the pod. You can only connect to the pod through a service from an external uh, from outside the cluster. So if you look at the pods itself have something called a pod IP. Or you can see it has something called a pod IP, which you can connect to from inside the cluster. But we want to connect to it from outside the cluster, right? So we don't have an external IP address with which we can connect to. So an easy way of doing it is, since we saw that our API server has an IP address already, we can use API server as a proxy to connect to the pod that is running. For that, we need to create a kubectl create service. Not sure of the usage, so I'm going to look at the help command, right? So I'm going to create a service with cluster IP. Terms, you can always go back and Google to understand these terms. Cluster IP is something which is available only inside the cluster. And what I'm going to do is I'm going to call it nginx again. I will also need to see that I also need to tell the service what pod should it redirect to, right? For that, I'll have to give a label selector. Okay, we'll do that in the meanwhile. Let's do this. Get one TCP port must be specified. Hyphen TCP say 80 colon 80. So this maps my service port 80 to the port 80. Okay, service nginx got created. CTL get services. So again, it shows us that nginx is there. Now nginx hyphen o YAML. Look at the YAML for this. It says selector app colon nginx. So any pod that has this label called app colon nginx will is gonna get traffic when something comes to the service. So get pods hyphen ORR. Let's see if our container has this label. Okay, so there is a label which says app colon nginx, right? So it's all cool. We can use it. Now what we're gonna do is we're gonna run the proxy again and see if we can access this. Default, even default, API namespace services service name. API namespace services. And what do we need? Slash proxy, right? I'm missing something. Namespaces. Yep. And namespaces default services. It says there are no endpoints available. Let's look at kubectl get endpoints. It is an endpoint nginx that is available. Okay, so let's see. So what we have here is it says there are three couple of ways to connect: node port or load balancer, proxy. Uh, okay, so let's try the kubectl cluster info command. Awesome. So this is gonna show. It is showing us couple of available proxies. So our nginx is not showing up here. Let's see why how that could. What the reason for that? Looks like I'm missing something. Okay, let's look at Kubernetes dashboard. Okay, I'm gonna override this for now. Okay, so you have to be logged in to access this. So if I look at nginx and root system, I will say default. Okay, again, again. Okay, so something wrong going on. Let's quickly resolve this situation by making use of something called port. Okay, so I'm going to edit the service. And I'm going to say type here it says cluster IP. I'm going to change it to node port. And I'm also going to say that node port is 30080. Okay. So let's look at load balancer. What this is going to do is to create a load balancer for me. So kubectl get svc. It's saying my external IP is pending. Still pending. kubectl describe specific in creating load balancer. If you look at our Google Cloud Console, you can see that there could be a load balancer getting created here. Okay, so it's saying created load balancer. So when I do, I get this external IP 335, 200, 135, 137. I go to this IP, I can see my Nginx is running, right? This is exposed via Google's load balancer. This is the load balancer IP that I got. So I have a pod running. I have a service that connects to that pod, which has an external IP. So these are the very basic concepts of Kubernetes. You have a pod, which has a container. Now it has there's an external IP attached to service. Any traffic coming to the service is sent to the container, and the response is sent back. So now what we can do is we can see how to put our own image in this container in place of Nginx, right? So right now Nginx is running. We would want to host our own application. So what you need to do is, let's say I'm going to create uh, my app. I want to create something called my app. What my app is going to do is, it's a simple application. Let's say, what do I do? Okay, so it's a simple Go application which is gonna say hello world. Okay, so I'm gonna create .go file where I'm gonna write my Go code. So I'm gonna say page main import a couple of libraries to be imported. Slash http is one of them. So I would say function main. So this part I'm gonna copy from somewhere else. Colon hello world. So I'm just gonna copy paste a bit of code from here. Yeah, so this is all I need. Change it to hello world. Cool. So I'm gonna just change it to fmt dot def fmt dot f printf. This is not required. So what it's gonna do is, whenever a request comes at localhost 80 or 8080 edge on the server at slash, it's gonna say hello world. I already have Go installed, so I'm gonna just run it and see. Okay, there are a couple of things. This log.fatal is not there, so I'm just gonna import log.fat log. Empty also I have to import. And right now, if I go to localhost 8080, I'm gonna see. Oops. I'm gonna see hello world, right? So this is a simple Go application. So now I need to make this into a Docker image. I'm gonna write a Docker file. I'm gonna say from Golang. I'm not sure whatever. I'm not giving a tag here. All I'm gonna do is copy dot go to main.go. we're gonna say that work directory also actually is also not required. And I'm gonna do go run the cmd could cmd is go run main.go, right? Explain it. I'm gonna build this image here. Docker build the colon low dot. We're gonna bold the Golang image and it's gonna build this Docker image for us. So the next thing you need to send this Docker image onto the Kubernetes cluster is to have an account on Docker Hub. So you can just sign in, create an account, and push your Docker image here so that you can provide the same at uh, same image tag while creating the pod. So this is my Docker Hub, which I've already logged in. So whenever this build is complete, I'm gonna push this image onto Docker Hub, and which will get pulled on the Kubernetes cluster. So my Docker image is built. Check it. Docker run Golang hello. I'm gonna expose port 8080. So it's running at localhost 8080. Hello world is happening. So I'm gonna do Docker push. Yeah, so I basically have to do Docker tag. So my image name was called Golang Hello. I'm gonna tag it to my Docker Hub ID here, Shahid slash. So Shahid slash Golang Hello. Then I'm gonna do Docker push. This is gonna push it to docker.io slash Shahid. So all I need to do now when this push is complete is give this image name to my in my uh, deployment that I'm pod that I'm going to create. So it's very simple. What I'm going to do is to use a kubectl command called kubectl run and kubectl run. I'm going to look at the help for it. So it says, yeah, that's all I need. So kubectl run Golang hello equal to kubectl run Golang hello equal to Shahid slash Golang hello. Create a pod. Okay, it's create something called a deployment. So it's better to get introduced to this term also. A deployment is something that is used to uh, manage pods. Here a pod with certain name is created. It's container creating. A deployment is something that is used to manage the life cycle of a pod. A life cycle means whenever you make any update, a deployment can help you roll out this update. A rollout means a new version of this will only be whenever you want to make an update and you create a rollout, the older version will only be stopped when the newer version is up and running. So that means you'll have zero downtime updates and all. So what we are going to do here is we see that our Golang hello is running. So I'm going to edit my service nginx. and ask it to direct traffic to my Golang service. Okay, so I'm gonna change port to 8080. Selector app is Golang hello. So this is gonna direct traffic coming on to 80 on this load balancer to port 8080 of the container marked with app Golang hello. So I'm saving this. It's saved. Now I will go to my Nginx previous Nginx page, which should show me hello world, which is not right now. So I have to check my deployment, check the labels of my pod. I'm gonna check that. So get pods this. I'm gonna look at the YAML. I can see that it doesn't have a label called app, right? That's the problem. So I'm just gonna add that label, kubectl edit deployment. So here you can see that I'm going to edit the deployment, not the, or else a simpler way to do this could be add an existing label, right? So we can see that there's a label called run Golang hello already available. So we'll edit the service and change this app to run to direct traffic to that. Okay, so that's all we need. Go and refresh. We can see that hello world is available. So So now another interesting thing about Kubernetes is, or the most important point about Kubernetes is easy scaling. So let's say your Hello World application is so popular, you have a lot of people using your Hello World application, right? And you need to have you. There are two types of scaling. One is horizontal scaling, another one is vertical scaling. So vertical scaling is when you can you when you increase the CPU, RAM, etc. available so as to handle the more increased use of resources. Another way of scaling is called horizontal scaling, where you increase the number of application copies of the application that is running. So Kubernetes gives you a native way of scaling your application. All you need to do is kubectl scale. I'm gonna say deployment slash Golang hello hyphen replicas equal to, let's say, 3. I made a typo here. This should be deployment. So it says deployment Golang has scaled. If I look at kubectl get deployments, it says that desired is 3, current is 3, available is 2. It it's still available 2. It's gonna create a third one also. So in the meanwhile, if you look at the pods, you can see that there are 3 pods of Golang hello running. So it would be nice to see which pod each request is coming from, right? For that, let's identify a act unique name for this pod, which is available in the inside the container. So you can SSH it to the pod using a command called kubectl exec. I'm gonna say it's an interactive mode that I'm gonna do, and give me bash inside this pod. I'm inside the pod right now. What I'm going to do is look at the environment variables to see if there is anything that is uniquely identifying this pod, right? So I can see that host name is the pod name. So host name is a unique identifier. So I'm going to modify my code to print out this host name also. So we main.go. I'm going to get this environment variable. So I'm going to say hello world from, and this will be os dot. Okay, I need to Google that. Get environment variable Golang. So os.getEnv, right? Os.getEnv host name. Now when we go to slash, it's going to say that hello world from that particular pod. So whenever three pods are running, what Kubernetes is going to do is, because our traffic is coming to the service object, Kubernetes can decide which pod it should redirect the traffic to. We have three copies running right now, and okay, I'll push again. I'm going to push it. So right now, okay, I'm also going to do a version name for this. I'm going to call it version v 1.0. Okay, this is called a Docker image tag. So I'm just going to push it again. So now when I say change my current, okay, this should be fun if you watch it side by side. Okay. So right now we have, I'm going to say watch SQL get pods. Okay, so we can see that. I'm just gonna zoom out a little bit so that it's nicely disappearing nicely. You can see that three Golang pods are running. Now I'm gonna do kubectl. I'm gonna change the image to this one, right? Kubectl. Let's see. Not sure what the command is. Kubectl rollout. Okay, so basically what I need to do is kubectl edit deployment Golang hello. When I do, I need to update this image, right? And update this to version 1.0, which I just created with the code to print out the host name also. So the moment I do this, watch here what happens, right? I'm going to edit, make a change and see what happens. Made the, see, the old ones are getting terminated, new ones are getting created. So until all the old new ones have started running, uh, okay, there is some error. I should have run my code locally and checked for run main.co. Syntax error. Oopsie. Yep, I forgot a bracket here. So I'm gonna build this again. I'm just gonna call it v1.1. I'm gonna push this. So you can see that my application is crashing right now. But if I go and try the page, I am still getting hello world. This is because Kubernetes is not gonna stop any running containers, running pods until there is another running one available, right? So if my new update is gonna cause problems to the, if my new update is crashing, it is gonna keep the old one still running so that there is no downtime. So my Hello World application is still running. My new update is not rolled out completely because it is crashing. So I have fixed the error, I have pushed the code. I'm gonna edit my deployment again and I'm gonna change it to 1.1. Fully this should work. And you can see that it's applying the new update and it's hopefully it should work. So run. Okay, I should have tried this again. See, main.co 14. Yeah, this is the problem. I forgot a curly brace. Yeah, now this time I'm gonna run it and see if it is working. Okay, it's working. Cool. So I'm gonna build it again. But We have deployed two updates with errors in it, but our application is still running. That's the kind of features that Kubernetes provides. So my V1.2 is built. I'm gonna push it. So once that is pushed, I'm gonna edit the deployment again to V1.2. So yeah, the push is complete. I'm gonna edit the deployment to V1.2. Hopefully this should work. So it's recreating all the containers. As we can see, one is running, two of them are container creating, one is still crashing. Yep. So two of them are running right now. Yeah, we have three of them running. Now that Kubernetes sees all three are running, it's gonna terminate the old one. Okay. So the service object that we created earlier, which is kubectl get svc, we saw that all the traffic is going to come to this. Anything that is coming to this external IP is coming to this Nginx, uh, which we have called Nginx, right? Which is right now directing traffic to our Golang Hello application. So what this means is it is also load balancing across these three containers. So if request one goes to one of these, request two is going to come to one of another one. We can see it clearly because we have added the host name value here now. Hello world from this one, 5D96C. Okay, all traffic is going to one. See, it's changed right now. See, we can see that it sends the traffic to another container. 53XNB is going to this one now. Refresh, and I can see that it's now going to now at 87 HMB, right? So this is this one right now. So this are couple of features that Kubernetes is going to give you, and this is a basic uh, idea about Kubernetes. You run containers as pods, and there are top level objects like deployments, which is going to help you roll out updates and all. We deployed an update which had errors, but still our application, the old application was running. And only when we deployed a new version with proper code, it took down the old copy of the application. And it can load balance across all these three copies that are running without any extra configuration. So that's all I wanted to cover for today. And I'm just going to take a quick look at the comments to see if there are any questions. So Divyanshu Kumar says in the Docker file, from line is not required. I'm not sure what that means. In the Docker file, you need a from line to say from what you are creating this Docker file from. So the idea about Docker file is that you start from an image and you what you're gonna do is you keep adding your own stuff onto it. So for example, the Docker file that we created here, I started from Golang, right? So what this means is Golang Docker Hub. If I look at this, there will be something called library slash Golang. So what I did was use this as a starting point. So what that exactly it is built from this all this Docker commands, right? So I'm just using this existing Docker file as my starting point, and I just added my source code and I ran my source code on top of it. So that is how Docker images are built. You keep adding one thing over the other as different layers, and it is very evident from the other stuff. See, it is pushing layer by layer, right? So that is how Docker images are built, by adding one layer on top of the other. So Let's see. I hope that answered the questions. What is YAML? YAML is just a format to represent data, just like JSON. It's just a readable, human-friendly version of JSON without the codes, the curly braces, etc. So that is what YAML is. Any other questions? Otherwise, let's wind up. And I hope this was informative for you running a Kubernetes cluster. There is also something called Minikube, which will let you run a Kubernetes cluster locally in your own system. You can also try that out. So I hope there are no other questions. Awesome. Then see you next day with a new different with another topic. Bye bye. Good night.